have an excellent talk from Dinesh Venkatesan and Aditi Bhatnagar, who are coming to us from Microsoft at Hyderabad. So I believe that Aditi is going to be kicking us off with this. Are you there, ready to get set up?
Thank you, first of all, the organizers, for giving us this opportunity to present the work. And hello, everyone who is watching this right now. So today we will be talking about the privacy posture of apps ecosystem, particularly Android. And before jumping into the technical details of it, let's first introduce ourselves. I am Aditi. I'm an engineer and researcher. My major interests are in technosociology and passionate about studying all the different aspects in which tech shapes human life. I'm a digital well-being advocate and an avid blogger. And with us, we have Dinesh.
Hi all. I'm Dinesh. I am a malware researcher, and I have been studying about various security threats for the best part of the last 2 decades. And I like knowledge graph, and I am in a lifelong pursuit of building a knowledge graph of all security threats. I am very much interested in building intelligence system that has the ability to do causal inference, and we will talk more about that in our case studies. Over to you, Aditi.
Sure, and thanks, Dinesh. Just beginning with the disclaimer that all the opinions are our own and does not necessarily reflect that of our employers. So let's talk about the functional perspective of privacy today, like understanding the context as to what privacy stands for in the real life. And as we go in the presentation, we will try to map it in the digital world and talk about the posture there. So privacy is a very basic human instinct, right? All of us live in our homes. We have houses surrounded by walls. We control the doors for letting people in and out. In real world, if someone asks us a question like what's your exact address or phone number, we get suspicious for sure. And most of us, like some of us, put locks on main gates for security purposes. So it's like a very basic gesture that human beings relate to. And it's very contextual, like privacy for me might not be privacy for you. So definition is really abstract. And I think that is what makes it really challenging to map this humanly expectation into a digital sphere. But still there are common themes attached to this, which we can all relate to. And that's what we'll talk about. First thing is autonomy. So why privacy? What is privacy protecting? So if you think about it from a perspective of technosociology, we'll say that it's giving, in a way, it's protecting our autonomy. Like how do we function, controlling our own lives, having the full freedom of how we choose to live our lives without the judgment or suspicion of any other person whom we don't know or people who have access to our information. So it demarcates that personal sphere from what we want people to know about us. And when is your privacy actually at risk? So imagine that my neighbor invented this elaborate X-ray device that enabled the person to look through the walls. Now, I would say that the person has the control to look at what I am doing, but that essentially doesn't, put my privacy at risk until that particular act is performed. So even if all OS, Android, or different operating systems have access to a lot of information, until that act is done, it is not affecting the privacy. And secondly, the most important thing is that who gets to see and what is it that they intend to do with the information that they acquired. So will it affect your autonomy if anyone is taking details from your devices? I would say it would affect it if it is affecting how you live your real life, right? So examples of it would be like if someone is taking details from my device and then presenting me information which can possibly manipulate my thought process, then yes, it is affecting my privacy. Another thing would be like, suppose some app sitting on my device collects some information and it's passed on to some servers, which is deciding whether I'll get a loan or not. So there's data flowing out of my device and that data is being used for my credibility or my judgment of whether I should be given a loan or not, then yes, it will be affecting the privacy. And similarly, it goes with surveillance. So if we know that, okay, someone is watching through the webcams all the time, the way people will behave will be restricted and that will definitely affect the way you live, right? So this is how, if you do a technical mapping, privacy will get affected if things are leaked from a system which we don't want to. So now mapping it into the digital spheres, let's talk about what happens in Android world. From technical standpoint or privacy, platforms usually try to ensure two things. First is that the users have all the control to provide or revoke consent on sharing data. So they should have the control. In Android, usually it comes in the form of permissions. And second is that the platforms itself is secure. So you ensure that the data reaches only to the legitimate consumers and is handled with proper care. So let's talk about the first and then deep dive into the second. So if you have an Android phone, what is it that you can control? So typically, a user on an Android phone can control, first of all, the apps that get to live on the device. Now, this is under our control most of the times, apart from the cases where the app is a system app, so it's coming with your phone, or if the app is mandatory by the law of land. In those cases, you don't have control, but other than that, you always have the right to decide what app is installed. Then the permission that that app can take, that can also be regulated by the user. And the configuration changes that the app can make. So suppose like turning on the accessibility service or device admins, those things can be controlled by going to settings and then deciding the controls for that particular feature. But now let's talk about what a user cannot control. So most of the users, Android users, have this thing that if I'm giving a permission, then I know, okay, this is going out of my device, but what is the real scenario? So info can go out even without any permission. And here's a small Jon Snow app that we made. So this particular app has not even a single permission, not even the normal permissions that Android can take without user intervention. Android app can take without user intervention, but let's see what all this app can get from the device. So here is a Jon Snow app, which we think knows nothing. And there's no permission given to this app and no other explicit settings. Now, when I go to the app and ask, what do you know? Now it'll tell me you have the Google Pixel 3 basic device details, the ABIs, the bootloader, all the digital details, which is, I think, okay, fine if they know. Then they would know whether Adb is enabled or not, or USB mass storage is enabled, or whether my Wi-Fi is on or not. They'll know what kind of accessibility services I'm using. What are my preferences? Is there any parental control on my device? They would also know all the apps which are sitting on my device. Now, essentially, every app that I use has a trait associated to it. If I'm using an HDFC Bank app, it means that, okay, I don't use that, but if I use that app, it means that this is my bank account, right? Most of the cases. Similarly, if you use any other app, basically it is a characteristic trait which can be used, and any app on Android can get access to that, all the different apps which are sitting on your platform. Then we ask, is there anything more that you can know? So this is the question we ask next, and let's see what is the answer. So further, the app can tell when will my alarm trigger next? When will I wake up next, according to alarm? Am I listening to a song right now? Is my microphone on mute? Is my battery charging? What is the last text that I copied? Which is, according to me, an important information. If you use copy-paste in mails or chats, this app will be having access to it. Then the sensors and all the app widgets that I'm using. So this is information that this app, which practically has no permissions, can get from the system. And I'm very sure there's a lot more to it. It's the first trial of conducting this experiment. And the normal permissions are all these permissions that you can see on a screen are normal permissions, which mean that user doesn't have to give consent on these permissions, but still this data can be accessed from the device. And this is like a lot more comprehensive than what we have just seen. So including the Wi-Fi network, the MAC addresses and everything, which we can get using these permissions. So things that this inconveniently lead to is firstly user profiling, as we see that, as we just saw that, in apps, every app is a trait. So if an app is able to collect all these things, the app would definitely know about my digital habits, how often do I open my phone and different things like that. And all that can definitely lead to user profiling. In fact, there has been significant research, which you can see quoted on the PowerPoint, where they were able to clearly find out the gender of the person, ethnicity of the person, and different things related to that person. So personal traits of the person can be figured out just on the basis of this information. And the second thing it can lead to is device fingerprinting, which is a notion very common in web, where we try to fingerprint the browsers. But in Android, that surface just increases. So it's a lot of data points on which you can easily figure out that this device is unique. Now let's shift the focus a little bit on the alternate angle of looking at privacy. So when you give access to it, is it that you're just permitting access for your data? So humans are interconnected and so is our data. There's no isolated zones in data. So when you give access to your contacts or location or different things that you choose to share, that same information includes your family or friends contacts and photos as well. So that also goes away. Similarly, when I choose to share my location or Wi-Fi state, my flatmate's location and Wi-Fi state also goes away. So it's kind of interlinked. So similarly, so the problems that privacy and security researchers usually see in this domain is this curious case of crowdsourcing, where say we have Alice and we have Bob, and Alice shares her number with Bob, and then Bob installs some app which takes that number and put it on cloud. Alice gets to know about that information, that it's on the cloud, and she gets disappointed that it's on the cloud. So she raises a request that, hey, just take this information away from the cloud because this is my personal PII, this is my personal information. But again, if third person comes here, Carol, and Bob shares the contact with Carol. Now Carol chooses to upload the information. They don't exactly choose, but suppose they have some app that took the permission and shared it on the cloud. Again, that would lead to the same problem, and Alice will be disappointed that her data is on the cloud. So basically it's a thought-provoking question on how do we approach such kind of problems, because there's no clear, well-defined solution on how do you want to tackle this kind of situation. Can a person actually control what amount of his or her information is on the cloud? So that is getting challenging. The other question that we touched upon was like, who gets to look at the data? Now, I'm not saying that we just should not share any data. That's not possible. If I want to use map apps, obviously I have to share my location because the utility will be provided using the location. So apps that need context to perform, legitimate apps which handle the data with care, definitely we share and we assume it's secure because we trust into the system and the owner of the app. The people who build the app. Second thing is the ad libraries which are into legitimate apps. So because of the premium version of model of revenue in Android, the apps will give you services, but it won't ask you to pay. So they use ad services and we trust those services. So in both first and second case, the things will go wrong until and unless the data is not handled rightly. There have been significant policy changes and introductions to make sure that data passed through these are handled with care. But things like programmatic bugs in your program, putting information in logs or handling the data wrongly, or if the data servers themselves are in attack, then definitely we lose out our privacy in those two cases. But the third one is what we are interested in and what we will be more covering in the technical details in coming slides, which is adware embedded in POA and PHA. So the first two are like they try to use the right ways of getting the information, but the POAs or PHAs that we study, they cross the margin and try to get access to data which they don't have the permission to access through indirect ways or shady ways, as to say them. And then fourth thing comes surveillance, where they can also get to see, which is a combination of privacy and security threats, but it's an ongoing discussion and out of scope for this presentation. So yeah, so this is kind of covering the different kinds of privacy threats that we just discussed, a little bit more details on them. And with having that context of privacy and its mapping with digital sphere, let's switch into the technical perspective of the presentation, where we'll be talking about the vulnerabilities exploited in privacy threats. So over to Dinesh.
Sure. Thanks, Aditi. Could you please move to the next slide?
Sure.
Yeah. So in this section, we will talk about some of the previously unknown tricks which were deployed in PUAs and PHAs and some of the cases were POCs. So we will first begin with an exploitation of a boundary condition check and how it helps a PUA to attain a certain privilege which otherwise would not have been possible. Before diving deep into the concept, let's talk about some of the background details. In Android, if an application wants to draw a window that has to appear on top of every single app, it has to acquire a special permission called system alert window. And and all the system windows have certain numbers associated with it. If it is an error window, there is a number 2003. If it is a phone type window, there is a number. And what happens here is, in the implementation, there was a flaw. The lower bounds condition was not being checked in the implementation. Hence, some of the PUAs in the past have utilized that unknown vulnerability, and they have set the value, passed the window type value as 0, so that the system draws it as a system alert window value. So using this vulnerability, the PUAs were able to draw a system alert window without having the necessity to get the system alert window permission from the users. This was already fixed, and let's see a demo in action. Aditi, could you please move to the next slide? Yeah. So as you could see here, so the device has two applications. One to show how the permission will generally look. So this is a harmless app. So it will require draw over other apps. That's the explicit permission it will ask from the user if it has to draw over other apps. But now we see an app which uses this exploit. So you could see there is no permission requested from the user, but still it will have the ability to draw a system alert window. So now this is a system alert window where it will appear on top of everything else. So the user will not be able to use the device as long as the other coercion happens in the background. Please move to the next slide. Another unknown trick is some of the PUAs, they were creating a user experience issue by creating a flood of permission requests. So again, before talking deep into the details, let's talk about the background of this functionality. From Android 6.0 onwards, a new dynamic permission model was introduced in Android, so that all the apps will no longer get the permissions during the installation time. Instead, the permissions will be sought from the user as the app runs. So the condition for this dynamic permission model to be active in the devices, the apps has to target at least 23 and above API level. So when an app tries to access the dynamic permission model, it will pop up a window giving a rationale for the reason why the permission is required from the user. And this pop-up is done by the system level APIs. So there was an implementation bug in the way the permission request is transmitted to the user. So using that, an app can trigger a flood of permission requests, which floods the screen of the device, and eventually the user ends up clicking on the allow button. So yeah, we'll see the demo here. So as you could see, there is a flood of requests. Instead of showing two requests, the PUA keeps coming up with the new dynamic permission request flood, irrespective of whether the user clicks allow or deny. As long as it is allowed and the next action is performed, it will continue to pop up even if you close the app. Next slide, please. Again, this issue was also fixed, and this is how the fix has actually happened. And the fix was implemented with the introduction of a private Boolean flag, M has current permission request. And as long as this flag is set, the system will understand that already there is a permission request going on. So there is no point in allowing another pop-up to happen. However, this hurdle was also circumvented by the PUAs and PHAs. We will talk more about it in the next slide with some background information. So this trick is not entirely unknown. However, the actual exploit is not unknown or documented. So the root of the problem is with the reflection. Long time ago, when we were young in the industry, we just noticed a this behavior that we can use reflection to access private data structures of the programming language. So being curious, we reached out to a forum and asked, is it not a violation? And of course, it was working by design by then, but we kept tracking this and how it evolves. Next slide, please. So in JDK 9, eventually, after 10 years, the access to the reflection is now made as an warning behavior. Like if we run the program with accessing internal data structures of SDK APIs, it will throw you a warning, and in future releases, it will get removed. Next slide, please. So this shows when the same program is executed using the recent JDK, you could see the warning, and when it is executed using the older JDK, it simply runs well. Now, how does it relate to us and the topic being discussed? So from Android 9 onwards, the same behavior is implemented where certain APIs, internal variables, methods were prohibited from being accessed or modified via reflection. We will talk about the circumvention now. So now what has happened, the M has current permission flag is accessed via reflection and manipulated so that even though the flag is already set, the flag is reset to false so that the permission flood is triggered again. We will see that in action now. So this is a Android device running 8.1, and it is having that fix already baked into the platform. However, using reflection, the flag is altered, and hence the permission flood happens in the fixed version as well. Again, this is also now fixed. It is no longer a threat, but some of the devices, older devices, which doesn't receive the update, will continue to get facing this issue. So with that, I will hand over to Aditi to talk about the rest of the vulnerabilities.
Yeah, thanks, Dinesh. Talking about the next one, which is exploiting broadcast receivers leak. Now, most of us would be familiar with safe mode, right? Like whenever there is some unusual activity on my phone, I'll go to the IT admin and say, what's happening? The person would say, reboot it in the safe mode. And we expect that malicious code won't execute anymore because safe mode has to be implemented in that way. But there was a vulnerability in the device admin receiver in Android. So apparently, in the PHA, the potentially harmful application, registers itself as a device admin for the app. And even when the mobile is rebooted in the safe mode, when we try to deactivate that device admin, a callback goes to that app and gives an opportunity or window to execute malicious code. So let's see how it happens. So here I'm rebooting the phone in safe mode. I already have the app installed, which is a potentially harmful app, which is causing trouble on the device. So you can see it's in the safe mode on the left lower bottom. Okay, so I go to the settings and I try to take the device, this particular app, out of the device admin configuration. Now, when I click on deactivate, the ideal behavior is just deactivate the app and don't give the control to the app. But here in this case, the control goes to the app, and again, it's able to pop up the window. So this is pretty naive, not doing anything. But in the actual case, the adversaries were able to do malicious things in that window of opportunity. This bug is again fixed in the latest versions of Android, and we don't see it anymore. Then there was another very interesting trick, which was exploiting the string. So the apps have the Android label thing, right, which decides the name. So this vulnerability basically made that value of the label too huge that the package manager, the package installer, which maintains the installation and uninstallation of app, throw an error, and we are unable to remove the app from the device. So here's a demo for that. So on the right, you can see the long string, which we set as a label name. And on the left, we are trying to uninstall the app. And we see that we get a warning, it's not uninstalled. So this is a prompt from the installer, and then it has a stopped because the issue occurred because of the huge text string of the label of the app. So such kind of things are being exploited. This is also fixed, but these things have been exploited, and this is how they try to get to stay on the system, doing things that they want to, which is definitely in contrast to what we would want to on the system. So those were about the vulnerabilities. Now let's jump to a different section, which is client-side collusion, which is like a really active topic of research. We have had great talks on this topic even yesterday, and briefly we will want to touch upon the approach that we use to see this. So what is client-side collusion? Essentially, it's like two apps talking, but they shouldn't be talking. So rephrasing it, we all know the concept of permission redelegation. So it's like, I have an app which takes my location permission. I have another app which doesn't take my location permission, but the other app has my location. Now, how does that happen? So we see this very commonly, that two apps can talk on Android using different things. Either, the side channels, as was talked about in the paper, 50 ways to leak the app by search. Or otherwise, we can have direct ways of communication, like you do content providers or you do broadcasts. So those are like valid ways which are allowed through Android, and two apps can use that to communicate and share the data which is allowed only by permission. So how apps interact with each other, that got us curious, and we wanted to find out different ways in which we can actually figure this thing out. So the challenges that come is that if you try to do static analysis of the code, the obfuscation of sometimes is so heavy that it's really, we are unable to make sense of it, that, okay, these things is calling the content providers and sending it to the other app. So it gets tricky. How do we actually ensure it, that these two apps are talking? Other than, the different approaches of studying network traffic and then reverse engineering the apps, is there a different way in which we can find out two apps are talking? So the approaches that we took to study these kind of client-side collusion cases was first a sneak peek into the binder calls, and another one is the graphical way, which Dinesh will talk about. So let's talk about the binder calls. Now it's Android, right? Every inter-process communication goes through binder, which sits right in the kernel. So irrespective of code obfuscation, if any two apps are interacting, binder will always know. So whether it's through content provider or broadcast or anything else, the binder is the person who would know it, right? So now the question comes that, can we know what binder knows? So it turns out that yes, we can know it on a rooted system though. So either you need emulator or a rooted device. When you go to this particular path, a sys/kernel debug binder proc, we see that there are a lot of log files which look like this, the text that appears on the screen. There's something called proc 770, which is kind of clear that 770 is a PID here. Then we have some rows with node, starting from node, and then we have other rows which are starting from reference. So it turns out that the node, the rows which start with node are the nodes being owned by this process, and the reference ones are the nodes which are owned by some other process and being referred by this particular process. So having this information, so we try to conduct an experiment on, can we find information out from these dumped logs? Now the problem here was like PIDs keep on changing, and they change. It's not that you kill the app and resume and the PID changes. PID just keeps on changing in between, like while the app is working as well, without any switch in the experience of the user. So if PID keeps on changing, our entire logic of finding out which app talks to whom will fail. So the approach that we took here was like, keep polling the data. So we get all the proc files, and we get the output of the command PSA, which tells us which package has what PID at this particular point of time. And then we try to figure it out as to who's talking to whom. So here's a demo for that. So it's a basic bash script and a Python script. So we see that the interactions folder is empty. On the right side, we have this Adb Shell. We have a device attached. The device is rooted. Now we do the Adb Shell. Let's have a look at what is in the path we just talked about. So when we go to the path, we see a lot of log files. We picked up proc, but the other folders, which is the state stats, are equally interesting. In proc, we see all these things. These are basically files. The number is the process ID. And when we open this file, it looks like the one that we just talked about in the slide before. Similarly, when we do PSA, we get the PID and the name of the service or app or process which is executing, which is having that PID at that particular point of time. So we get output of this, this command, and we get all the proc files, and then we try to run the script. So once I run the script, we'll see that it'll fetch everything and try to make sense of it. So this is the output that we get. Every file is basically a process name, and then when we open it, we see what are the other services or processes that this particular app or service is talking to. So like for system server, it talks to most of the things. So you'll see a huge list here, and these are the things which it's talking to. So we found it a really interesting approach to study these kind of collusions. The final results of what we found, we'll be publishing it soon. The other way is the graphical way, which Dinesh will talk about.
Thanks, Aditi. Before we talk about the approach we have taken, I would like to talk a few minutes about the concept of knowledge graph. Next slide, please. Yeah. So knowledge graph, as most of us know, has been a very famous technique ever since 2014 when Google has popularized it as a concept. So it is basically an elegant way to consume graph-shaped data. When I say graph-shaped data, they are basically triples having two entities sharing a relationship between them. And the whole idea is to represent the entire knowledge about parsing an APK and documenting its behavior and its static relationships and properties in the form of nodes and edges, so that we create deeper connections among this structured data. And that really helps us from data to information to knowledge to wisdom path. For example, since as I've told in the introduction slide, this will be very useful in causal inference. Let's take a very simple example of difference between fact and truth. So often the intelligence system is able to derive intelligence, and how do we differentiate and provide reasoning? For example, this 3 plus 2 that equals 5, it's a fact, whereas the reverse is not actually a fact, it is only a truth. 5 is equal to 3 plus 2 can also be 5 is equal to 4 plus 1 or 7 minus 2 to infinite ways. So how do we differentiate these things? It is not only about similarity analysis, it is all about a combination of many things like similarity analysis, dissimilarity analysis, to track the evolution of how a PUA grows or evolves from one variant to another variant within the same family, how different variants behave and things like that. So the essential point here is with the proliferation of data in all the fields, the answers are everywhere. The answers are not a problem anymore. It is all about asking right questions, and knowledge graph is one such means to enable researchers to ask right questions or navigate the researchers to ask right questions. Next slide, please. So as you could see, we will also show you a live demo. The APK is parsed along with reinforced behavioral data as well with a node and the relationships. And you could clearly see in this case 2 samples, each having some specific attributes and some shared attributes. So the specific attributes are well just here because these are like adware. That means adlib embedded applications. So the specific attributes that you see is corresponding to the application code, whereas the shared genome that you see is the add SDK attributes. So between these two apps, the only similarity is the genes that comes from the advertisement SDKs. Let's quickly show you a demo like how This also can enable tracking intelligence and evolution of the samples and variants. So for this demo purpose, we are using a fantastic open source project called Kele. So generally, this knowledge graph is consumed better in an efficient manner through the client, through the command line version. I mean, Kele also has many Python bindings, JavaScript bindings, and things like that. But for better demonstration purpose, we are switching to the visualization mode. So as you could see in the screen here, currently we have plotted 2 samples in the graph format. And as I've emphasized, it is not only about what are the common things that gets shared between these 2 variants.
So I think we've lost your screen. Put this back.
Oh, okay.
So Dinesh, you want to share the screen, or we'll continue on this?
Yeah, thanks. Okay, I think I cannot start screen share while the other participant is sharing. Can you close the screen share?
Yeah, sure.
Okay.
Okay.
Yeah. Okay, so yeah, let me start the execution. So let's switch to the visualization mode, and we are plotting 2 samples in graph format. And as I emphasized, it is not only about the things, the attributes or the behavior that these 2 samples share in common. Some of the significant things can come from the difference as well. What is the dissimilarity index between these 2 samples? You could see this sample is almost similar with the other sample, with the only difference being voice recognition SDK. Now, for a researcher, this is an interesting piece of information. More than the similarity, it gives an indication that the sample has evolved to add voice recognition capability. So we may want to do a deeper analysis for this. So in a larger system, this becomes very useful, and we will show you a quick demo before we hand over to further sessions. So as you could see, the properties, how they are intertwined, and the similarity and dissimilarity index is calculated. So with that, I will again hand over to Aditi to talk about some of the privacy improving evolutions that has happened in Android over the past 10 years that has significantly improved the privacy landscape.
Sure. Thank you, Dinesh. I hope the slide is visible. Just navigate 1 second. So yeah, so we just saw what all kind of things we can get from knowledge graph, and that ends the client side collusion techniques section. The things which can happen, the advantages that it gives us in the case are being discussed. So the first one is for sure the obfuscation kind of, you can, not worry about that because you'll get to know if 2 apps are talking. But yeah, there are other problems that you would need to automate the operations on the app, and you would need rooted devices or emulators. So that was the conclusion. And now let's jump into the section evolution that improved privacy. So Google has been very active and has added a lot of amazing things in the Android ecosystem, which has helped prevent most of the things that we talked about in the previous slides, especially the cases of like proc FS access denial. So previously, like any app can access the proc files, and you'll get to know about your network details, what all internet connections you made, because the TCP log was also there, and your ARP cache was there. So those files were like apps were able to access it, and with this setting, the denial has been made. And then there's a whole revamp dynamic permission model, which has come into play, which will definitely change the scenario a lot, along with the deprecation of system windows and background app restrictions, changes to side loading policies, and changes to reflection access. So most of the things that we talked about, and the landscape is evolving, and a lot of things will be happening. So just excited to see how it goes, and at the same time, we'll keep on working on the things and share it with the community. So I think that marks the closure of the presentation. We would be very glad for any questions.
Great, thank you. So we're open for questions. So start thinking about questions you might have. We do have one question on Mattermost. It's from Renee. Renee, would you like to ask it, or would you like, or I can read it?
I can also ask myself if that'd
be great.
If you prefer that.
Yeah.
So thanks a lot for that talk, and particularly to Aditi for introducing or bringing up that topic of the potential of sharing data, not about just yourself, but about others that you may have data on explicitly or maybe even unintentionally, for example, in photos or wherever. Now, this transitive consent, as I tend to think about it, I have no idea how to deal with that. How did you analyze any particular ways of how you could raise awareness both for the users who actually do the sharing, that they might unintentionally share something about others, and maybe also raise awareness of those users whose data has been shared by others? Do you have any idea of what user interfaces could do to make this maybe more explicit, or to just point it out to users that, hey, this is something that you may need to consider when doing that? Or do you want to transitively ask the other people that you are sharing data about if they consent, if they're okay with that?
Yeah, so yeah, that is like an amazing question. Thank you for asking that. I don't have like concrete solutions, but I do have certain thoughts on that. We all know that awareness is for sure lacking, as in because it's like when we deal in natural world, we know how to act when it comes to privacy. But when it comes to digital world, a lot of people see it as a device. They don't see it as a potentially privacy leaking gadget, right? So that understanding has to shift. I think it is happening, but more awareness is needed for sure. The way you present information to the user is one thing which tech industry is already working on, and I think it can be significantly improved. One basic thought was like, suppose when there's an accessibility service active on my device, right? I go to settings and I can see that these apps are watching, like these are enabled accessibility services. So if an app has accessibility service, it can see anything that happens on my screen, in fact, get all the text and do some actions as well, depending on what rights are there. So that information is available in the settings. When I installed the app, I had a look at it. And after that, I just use my mobile as is. So I'm talking about a normal user. And now when I'm going to suppose some browser and doing my searches, there's nothing on the screen that will make me aware that, okay, in the background, you know what, that app is also listening to what you're seeing. Right, so that awareness is not there, and it's also not very visually present on the device itself. So that those kind of UX kind of changes I think we can do, so that we know that there's a conscious leaking of information. Again, other than that, I think it's more of a UX thing. I won't say we have technical solutions to it, because once data goes out, where it will go, what will that person who has the data do with that, we don't know. So we don't map how data flows across geos and across communities or orgs. So yeah, it's definitely challenging, but making the user understand through UX, a refined UX would be a good first step. So, you know, rather than that terms and conditions like we see in web and we click, I agree, that instead of that, can you make it more visual? Or so why do we have to put it in text, right? If you make it more visual to make the person understand. So those kind of things, to me, it will lie more on the UX end as of now. But yeah, I'll refine my thoughts on that. Thank you for asking that.
Thank you.
So to augment Aditi's answer, apart from the server-side tracking that Aditi has shared her thoughts on, we are also looking at how some of the improvements can be done at the client side. For example, when when the same crowdsourcing is being applied, we have common platforms, be it the system level intents that can get fired on the recipient of the person whose data, the third party's data, which is getting leaked between the user and the vendor. And we are conducting few researches in that area, and some of the experiments. Probably when we release the data, we will be able to release the efficacy of those models as well. So yeah.
Great. Do we have any other questions? We're about out of time, but you know, I thought I'd kind of add something onto that. Are you guys familiar with the idea of contextual integrity? And thinking about, so if you're not familiar, this is something that Helen Nissenbaum at Cornell has been talking about for a number of years. And it's this notion that users should allow the use of their data under certain contexts. Now, one of the things that computer scientists have a lot of trouble with, particularly security people, is saying, how do we allow functionality to happen without having strong controls over that? And so I would be curious what your thoughts on how those sorts of models might be incorporated into an ecosystem like this, and how that maybe relates to the topics we were just discussing.
If I interpret the query correctly, are we talking about how do we enable context-aware computing without having to give up a lot many data? Is that correct interpretation of your query?
No. So this notion of contextual integrity is if you're not familiar with it, it's not really defined context from the perspective that computer scientists often do, but it's more about the use of the data, right? Okay. So we allow software to use our data with certain assumptions, and when those applications sort of violate those assumptions, then the contextual integrity is lost, right? And it's sort of about how do we inform the users how this information is going to be used, and then what ways might we be able to validate that? So thinking about some of the things you talked about at the end, right? You might be able to have other proofs of assurances that they're not going to sort of share this information with some other application.
Mm-hmm.
Yep. So I think some of the areas can be covered using the server-side collusion analysis and client-side collusion analysis, like generative adversarial method. I think, Aditi, would you like to also pitch in with your opinion?
Yeah, so it's a very interesting thing. So data is actually, it is what it's worth for based on where it's used. So which context it's used for, as you just said. And I think one thing which definitely goes wrong is that user has no knowledge of the algorithms running behind the scene, which will be using the data that the person has given and how it will affect it. So if anyone is asking a basic SMS permission, I give it, but then that app is reading my account transactions and deciding whether I'm eligible for loan or not. That thing I didn't know of, right? So that information needs to be, I think, communicated to the person who is sharing the data. I don't have a concrete answer on how we can do that. Again, it comes back to awareness, but or making it very clear in when the person installs the app. But I'm not sure how the developers would be doing that eventually. But yeah, that's a challenge. I think that is something that we have to address sooner or later.
It's definitely a hard challenge. So I think we're about out of time for today. We can't hear everybody clapping, but if you can have some virtual clap. Thank you, Aditi and Dinesh. And that concludes our first talk.